Size 20.4, but this is part of 20.3. As you can see, I threw in a graphic here down below to help me explain what's going on with this for the sample exercise or the sample problem. So the oxidation reduction reaction, then we have our dichromate, which is Cr2O7 minus 2, 14 H pluses and 6 I minuses, and then that goes to 2 chromium plus 3s and 3 iodines and 7 waters. So it says it's spontaneous, which means, think to yourself, does that mean a positive delta G or a negative delta G? Just to tie in some of the stuff we talked about last chapter, because we will get to that. A solution containing K2 Cr2O7 or potassium dichromate and sulfuric acid is poured into one beaker, and the solution of Ki potassium iodide is poured into another. The salt bridge is used to join the beakers. A metallic conductor that will not react with either solution, such as platinum foil, is suspended in each solution. The two conductors, why not platinum? Why does platinum foil not react? Because platinum is one of the least reactive metals, gold coming in right after platinum, I believe. And then also mercury and copper, but copper's, yeah, okay, anyway. So moving on, the two conductors are connected by wires through a voltmeter and some of the devices detect an electrical current. The resultant voltaic cell generates an electric current. Indicate the reaction occurring at the anode, which would be on the left side of my graphic, the reaction at the cathode on the right side in the direction of the electrons in migration, the direction of the ion migration, which means anions go which direction, cations go which directions, and the signs of the electrodes. Okay, so I have this second part, direction of electrons, direction of ion migration, and signs of electrodes. That is all stated for us already because of this graphic. So what we're going to do is place them at the correct places. We have the redox reaction. I'm going to break into half reactions. One of the half reactions that I'm going to show you is going to be, you're going to see this one quite a bit, the dichromate here has a -2, and then we have to, according to this, we have to include then, of course, the 14, electrons. I know that this is always a +6. I've done a whole bunch of these problems. So I know the +6 of each chromium ion goes to a +3 on the other side over here, like this. And because we have 7 oxygens, we need 7 waters like that. And what this ends up being, a +6 to a +3, is going in the left direction, which means the electrons are over here. What did I write there? I wrote electrons instead of hydrogen, like hydrogen ions. Sorry about that if I confused you. So that means that I have a total of +12 on this side and a total of a +6 on this side because I need 2 there, which means that I need 6 electrons over on the left-hand side. This is, I should have done all of this in red because this is the reduction. Reduction happens here on this side. So I'm screwing this up. I'm writing all this stuff over again. So that you can see what's going on here. And then over here, of course, will be the 14 H pluses, and then that'll be plus the 6 electrons on that side. And then over on the other side then, of course, would be, we have the potassium iodide, which means that we have not just potassium iodide, but it's going to be 2I minus, so it's a -1 for each one of those over here to the I2, like this, which means it's at 0, which means -1 and 0 here. It's going to the right-hand side. This is oxidation and anode. So that's what's going on right here, and it looks like on the right-hand side I'm giving up 2 electrons like that. So that's what's going on, which means on this side here, then I multiply this by 3 to get the 6 electrons, which means I have 6 here and 3 here, and that makes sense to us because that'll give me 6 electrons. Electrons are congregating at the anode. They are moving from the anode all the way over to the cathode. Because the negative electrons are congregating and then they're starting to build up at the cathode, that means all of the, what does it say is over here? That would probably be the pluses, the K pluses here, then is starting to build up on here because they're, now that's interesting because potassium metal, is very reactive with water, so this solution here Yeah, I don't know what's going on with that. In other words, we're not getting a buildup of metal on the cathode like we should, but the anode then is losing. So you can see the minus, the I minus here then is losing its extra electrons that are being placed on this electrode here. Now, what it says here is correct. The anions are moving in this direction, so that would be sulfate ions are moving over there. And the cations on this side would, of course, still be the K plus because we have the K there, and we also have the K over here. So the K pluses are moving to the right towards the cathode. The sulfates are moving to the left. So that's what's going on. I think I've answered all the questions. The signs of the electrodes are positive and negative. So I think that I just answered the whole question there, just showing you what's going on with a standard voltaic cell. Okay, I'm going to pause there. We'll go to the next one then in another screencast.